I sort of think it's changing the mindset when we're looking to purchase the instrument. Quite often we've seen that you look across a tray of instruments and you think the money's been spent across the seemingly the more important bits of the set. On an orthopaedic set, for instance, like the chisels, the osteotomes, and they've been bought from sort of reputable companies. But then people are potentially skimping on things like sponge holders and mosquito forceps and towel clips because it's perceived that they're not as important, yet potentially you can do is end up buying these cheaper instruments that perhaps necessarily aren't from the correct stainless steel, correct composition, and they can potentially affect the whole tray, cause rust potentially across the whole tray, and really risking the integrity of the whole tray itself.
Millions of patients undergo surgical procedures every single day. They place their lives in the hands of healthcare providers who are committed to delivering safe, functional and sterile instrumentation for every surgery. Working behind the scenes are the technicians who go largely unknown, even to the patients whose lives are so dramatically impacted by their work. This is Beyond Clean, the global voice of sterile processing. Join us as we explore this hidden world and introduce you to the unsung heroes who are driving the advancement of our profession. And now your hosts, Justin Poulin, Michael Matthews and Hank Balch.
This week on Beyond Clean, we speak with Daniel Coole, Managing Director at Surgical Holdings, an innovative manufacturer and repairer of surgical instruments and manufacturer of orthopedic implants, supplying NHS and the private sector in the United Kingdom. Daniel has over 20 years in the surgical instrument manufacturing industry and is the chair of the Surgical Instrument Special Interest Section for the Association of British Healthcare Industries. And Hank, this will be Daniel's second appearance on the show. So we're going back to the well a little bit in the past couple of seasons. It's great to hear some of our early supporters sharing their knowledge with us yet again, as we said that they would. Today we're going to talk to Daniel about everything anybody ever wanted to know about stainless steel.
That's right, Justin. We tell our guests often at the end of a great segment with fantastic content, and we want to have you back on the show, but there's so few opportunities to do that because there's so much great content out there. So I'm super excited to have Daniel back with us again. In particular, a couple weeks ago, he wrote an article, Surgical Instruments versus Water, that really caught my attention, and I thought that's the kind of content that we really need to get in front of the audience to have conversations about passivation and about rusting, corrosion, and all that in the context of stainless steel. So let's get to the interview and make this thing happen.
You can subscribe to Beyond Clean on iTunes and Stitcher, Google Play, and Spotify, or search for Beyond Clean on your favorite podcast application. We can also be heard on the Sterile Education app, available on iTunes and Android. Also, we have a number of resources to give away this season provided to us by Isham Amy, CBSPD, Rick Schultz, and Pavel de Sternberg-Stoyalovsky. There will be different ways to win every single week as announced on our various social media sites, so make sure to follow Beyond Clean on Twitter at Beyond Clean Info, Facebook.com/Beyond Clean Podcast, LinkedIn.com/company/Beyond Clean, our Instagram page Beyond Clean Podcast. And if you have a question or a future guest for the show that you'd like to recommend, send an email to info@beyondclean.net. Season 3 of Beyond Clean is brought to you by Healthmark and Consortia Surgical. Healthmark has intelligent solutions for your cleaning verification program, including products to measure water temperature, water quality, cleaning efficiency, and directly test for residual soil left on instruments. Find your tools for cleaning verification at hmark.com. There you will learn about their TOSI and SonoCheck that test the performance of cleaning equipment as recommended in sterilization standards guidelines. And Consortia Surgical, the industry's first group service organization with over 100 years of combined experience. They're unmatched experts in the field of flexible and rigid endoscopy, powered surgical handpieces, medical video imaging devices, and surgical instruments and table attachments set them apart as a leader in perioperative equipment management. Consortia was created with a primary focus on safety, customer satisfaction, quality repairs, and end-user training, providing their clients with measurable results, improvement, and cost savings. Contact them today at consortiasurgical.com or 844-394-8900. We'll be right back after a short break.
Beyond Clean.
Joining us now is Daniel Coole, Managing Director at Surgical Holdings. Daniel, this is your second appearance on the show, so we said we were going to start doing this, and I know we told you as much when we wrapped up the interview, I guess over a year ago, not too long after Beyond Clean kind of hit the market with the podcast. So we're really excited to have you back on the show, and we're going to talk about stainless steel today.
Great. Well, thank you to you all for having me back or having me back on again. And I'm a real supporter of what you're doing, and it's a pleasure to talk to Michael for the first time as well. So no, I'm looking forward to talking through some interesting points around surgical instruments again and stainless steel.
Excellent. Yeah, this is your first one with Michael, so we'll try to keep him from peppering you with questions. No, that's what we're here for today. And why don't you start off by telling us some of the bigger myths concerning stainless steel that are out there in the industry today?
I think there's a few myths really, and I guess the first one of them is around stainless steel used for surgical instruments or medical equipment being this sort of superhuman stainless steel that's very robust and can take anything that's thrown at it. It's a stainless steel that's used for surgical instruments because of its composition and its suitability in that respect. But it's by no means really specifically designed for surgical instruments. I mean, the name itself, stainless, I think that's sort of pretty misleading itself. It probably should be stainless rather than stainless. So I think it's for me the myth is that I think particularly when people are using the instruments, it's understanding a bit about that each instrument generally will have a slight variation in the composition depending on how the instrument is being used or why it's being used and if it's so it's fit for purpose. So I think it's really from the sort of myth perspective, it's understanding a bit more about what goes into the stainless steel, the composition of it, so we can understand where its weak points are and where we have to be, conscious of those weak points. And sorry, just to sort of elaborate on that a bit more. I mean, obviously, the vast majority of stainless steel that is used in surgical instruments will be a 420 stainless. So that's described as a martensitic stainless steel. It's carbon containing. But a big percentage of that, sort of 70 to 80% of that, is in fact iron, which obviously iron is extracted from iron ore, which in essence is is more or less the same chemically as rust. So there's our sort of first issue there, really, that although we're describing it as stainless steel, the majority of the composition of the steel itself, is very comfortable in a state where it can revert back to rust as quick as possible. So we've got to be conscious of that. Really building on that a little bit more, I think it's also understanding that you've got with regards to stainless steel, it's a sort of quite a unique alloy in itself that when it contains chromium. So chromium allows the instrument to oxidize and give it the what is this described as a sort of passive surface, or which is achieved through the process of passivation, which is just really the stainless steel oxidizing, the chromium in the stainless steel oxidizing with so on contact with oxygen. So this in itself, the passive layer that's on the stainless steel is very, very thin, around 30 microns thin in terms of the thickness. So we've got to be conscious of that, and that obviously if we're washing the instruments, if we're obviously using the instruments and reprocessing the instruments, this passive layer can be very easily damaged. And if we get some damage on there, which could actually be just through something like water spotting, depending on how the instruments are obviously washed and sterilised. If if it's purified water that's used, you could really damage the passive layer of the steel quite easily. And that's where we start to get concerned about things like corrosion and other processes like this that can initiate and obviously lead to the instrument failing.
So let me jump in there, Daniel. A lot of those points that you're making now, if folks don't follow you on LinkedIn, you had a fantastic article here recently called Surgical Instruments versus Water, and I know you go through a lot of in-depth explanation about that state. As you mentioned, the natural state is that they want to come together and be one. I think you said romantic relationship, and so our role in the sterile processing industry is to keep that from happening as much as possible. And again, there's a lot of fantastic content there that we'll link to in the show notes. But I want to, in addition to later on getting into the passivation layer conversation, I do want to go back to something that you briefly mentioned in the differences in stainless steel, because even though it's not a myth necessarily, I think there is confusion that all stainless steel is the same or all metal is metal. And, we don't have to talk the sourcing conversation specifically, although that could be part of it. I'm not sure, but can you speak to the differences in those categories of metals and particularly in stainless steel and the impact that has on the quality of instrumentation or the life of the instrumentation, for instance?
Yeah, sure. I mean, when you look at stainless steel and obviously different materials that are used for surgical instruments, it's all about really sort of common sense and what's suitable for the use. So obviously there are international standards. So ISO 7153, which outlines specifically which stainless steels are suitable for which instruments. So there's guidance on that. And the reason that there is guidance on that is because if we're manufacturing surgical instruments, so for instance, if you're manufacturing something like a chisel or an osteotome versus something like an artery forceps, there's a big difference in what the instrument's going to be used for. One will be used for chiseling away at bone, and obviously needs to be able to be hard, very hard, and obviously maintain a sharp edge. Whereas the other, obviously, there needs to be a bit of flexibility. So that's where the differences come in. And if you look at the stainless steel used in surgical instruments, which is generally 420 stainless, across the range of the 420 stainless, there's a varying amount of carbon content. So the carbon itself obviously allows the instrument to be hardened. So if you've got something like an osteotome or a chisel, you'll have a higher carbon content than you will in an artery forceps, for instance. So there's obviously a big variation there, and that's why it's really important when you're making instruments to ensure that the correct steel is selected, or the correct forgings or bar or whatever you're making for whatever the instrument, really. So that's really important. But of course, also adding to that, we mentioned about passivation. If you want the instrument to be fit for purpose, we're talking about washing the instrument in quite harsh conditions and sterilising it, then it needs to have the correct amount of chromium. Otherwise, it won't be able to achieve the correct passive layer, and the instrument just won't be fit for purpose. So I think, obviously, talking about different sources of stainless steel, I suppose one of the myths, to an extent, is that really good stainless steel can only come from essentially certain European countries. But of course, if the stainless steel is the correct composition and it's obviously ticks the boxes as far as all the different chemical elements are concerned, then of course it is suitable. So it's really just ensuring that, I suppose, when you're manufacturing instruments, that you do your due diligence on the material sourcing, that you're testing that material to make sure it is to the correct chemical composition, because otherwise, obviously, you'll manufacture an instrument, it potentially might fail if it's not made from the correct material, or it might not fail. It might just about do the job, but then it might not reprocess correctly. It might go rusty. Particularly when we talk about different water that's used. I mean, obviously, in the UK, so in England, I think it's now more or less mandatory that purified water has to be used, whereas in Wales, they use potable water, so essentially just tap water. And then obviously that creates different challenges, because obviously the sort of the natural tap water, no matter how pure it is, if it's got chloride in it, there's nothing like a bit of chloride if you've got a scratch on an instrument to initiate some sort of rusting or spotting. So it would seem very straightforward to say, right, we've got to have the correct composition, but I think it's having that awareness and education of what's beyond that. It's not just, we're not just talking about it's got to be the correct composition because we're going to use it for cutting or clamping. It's got to be the correct composition because we've got to wash it, and actually that water that's being used might be a completely different makeup of minerals in one area of the country versus another area. So there's so many challenges, really, I think, when we're using stainless steel. But you sort of think the easiest way for me to understand it is to look at if you've got your sort of dishwasher at home and you're washing cutlery, and some will stain, some will mark, and there's no real other reason that it's the same challenge. We're dealing with chemistries, we're dealing with stainless steels, and not everything's perfect, but we just have to be aware and try and educate ourselves as much as possible.
So, Daniel, we've talked a couple of times already about the passive layer. We really excellently described, what it is. Can you tell us why the passive layer is so important?
It's the only thing that protects the steel from deteriorating. I mean, once the passive layer is compromised, potentially free iron could be released on the surface of the material. Obviously, then that's going to initiate corrosion in one shape or form. It could potentially initiate pitting corrosion if there's chloride in the mix. So, if we're washing the instrument, there's potentially chloride that could be pitting, which can be quite difficult to detect. It can be almost like a pinprick, but underneath the surface, you've got in essence, a pit is created, and it can obviously the danger is that the instrument's being used and it fouls. So that's obviously why it's so important. It's obviously the only thing that's really protecting the instrument. And I think when people buy new instruments, sort of quite often people expect, as you would, that, if you buy a new product, but it should be in its perfect condition and fit for purpose. But a lot of the time the passive layer will be quite thin and it will build up naturally as you go along, because as instrument manufacturers, we artificially have to create that passivation process, which we can do with acids.
So, you mentioned free iron on the surface of the instrument, and you talk about the passivation layer being thin on initial purchase and then becoming thicker over time. I want to dive into those three areas. First off, to say that free iron, just for all of our listeners to understand what rust is iron oxide. So that free iron on the surface is why rust would then possibly present itself. Is that correct?
Yeah, that's correct. Yeah. I mean, obviously, you've got the instrument itself that has a large composition of iron. So that's the sort of the red flag is being aware of that. And it obviously, it's great. We're using iron because of its strength properties in an instrument, but we've got to be aware that obviously we're forcing it into a situation that we're using it for our use. It wants to, in essence, it wants to be iron oxide. It wants to turn back into rust if possible. So we've got to be aware that obviously the iron composition in the surgical instrument itself, and obviously the issues that present that. And of course, if you damage the surface of the stainless steel, you damage the passivation layer, and that free iron can be released.
So that passivation layer, you said you do that in the manufacturing process with acids. Can you describe that? How many steps is that process, et cetera?
It depends on what acid, really. You can either use, and there's guidance again this is why I think things are important to be a sort of level playing field with surgical instruments, particularly if we're talking about different sources of materials. There's guidance on the passivation process. People may use nitric acid. They may, it may be heated. A more popular option is citric acid, which is not as harmful to the manufacturing staff. So I think people tend to use it for that as well. So there's different acid products that can be used, and essentially what happens is the instrument is put into the acid for a period of time, and that initiates artificially this the same reaction with sort of the chromium, the oxygen, and passivates the surface of the stainless steel. So what's quite interesting about that is that there's actually an ASTM on passivation that I refer to, or that I use. Obviously, our sort of work situation, and there's a few good tests that you can do to check the passive layer and check that it's intact and passivation has taken place correctly. So that could be something for the listeners to look into a bit more, because we're talking about instruments, whether they're fit for purpose, then that could be something worth following up on.
And you also said, and I think that's a really good point, and maybe we can post those resources in the announcement for the show. Also, though, you said that the passivation layer can actually build up over time. Does that happen naturally? Does it happen chemically? Like, can the staff do something to help promote the passivation layer other than just keeping it free of debris, or does this just kind of happen over time?
I think it just happens over time, but obviously with repeated washing, it tends to build up. But then this is something that's never measured. I think it's just generally the robustness of the surface of the instrument after it's been manufactured and laser marked and then passivated. Sometimes you can get a bit of staining around the laser marking when you first start to wash it. So it's just generally, I think it's one of these things. If you've got some really good old instruments that have been on the trays for a number of years, and you'll see that the stainless steel is still in a really good intact condition. So obviously in the UK we have lots of sort of down surgical instruments and McCarthy's, and you look at them and you think, well, how these are like 30 years old? How come they're so good? And it's just really generally the passivation layer or the passive layer is just built up over time, whereas manufacturing the instrument and artificially creating this process, if you like, this phenomenon, then it's not going to be as robust as it taking place naturally, just with the instruments mixing with oxygen and obviously water during the reprocessing cycle.
Daniel, that's great information. I know that we kind of just addressed another myth regarding stainless steel instruments, that typically people believe that the newer an instrument is, the stronger that it is. And that's not necessarily the case, that sometimes these brand new instruments that are coming in, they're coming straight from a manufacturer and they haven't had time to have that passive layer build up. So that's really great information. So kind of following along with that, we talked a little bit about what corrosion is and how it forms. Why is it that corrosion of the instrument is so dangerous to the patient?
I suppose it's ultimately, if the instrument's being used and it breaks due to corrosion, then I suppose it depends on what the instrument is, but there's obviously a patient risk there. From the other side of things, who would want an instrument that's rusty being used on them? You've got, obviously, if you've got rust on the surface of the instrument, potentially you've got other issues such as infection, or obviously we manufacture the instruments from stainless steel, from surgical instrument grade stainless steel, for the reason that obviously if they're treated correctly, manufactured correctly, then they're safe to use. Obviously part of that is having the chromium content so the surface can be oxidized, so the instrument's safe to use. It's not safe to use if it's rusty or if it's got rust on the surface. That's just obviously something that I think from a sort of the knowledge of of the public, they would expect in their hospitals for instruments to be in a safe working condition from a surface finish point of view, I would say.
Yeah, now, Daniel, you're singing my song there, because that's been a recent soapbox of mine to say, if patients knew, or if they had the opportunity to ask, are any of my surgical instruments corroded, or is there any rust on any of my instruments? If they had the ability to ask that question, and they ever got the answer yes, I think we all know they would go someplace else. And yet, in many departments across the globe, and this goes back to what you were saying, this is just the natural challenges of using steel in the context of water, or in the context of oxygen for that matter, which is always going to be the case. But if it's left up to the patient, they would not want that. And so as an industry, especially for frontline technicians, we've got to encourage those folks on the front line who can see this happen long before it gets to the repair lab or to the repair technician. These folks on the front lines, they see it starting. They see those color changes. They can see the corrosion pitting beginning, and that's really when that quality control has to step in and those items have to come out. I say that knowing the challenges as a technician, especially in these departments that don't have a large instrument budget. And the question is, well, I can put this clamp back into service. It has some minor pitting, or I can take it out. The tray's going to be down. The doctor's going to be frustrated, and now I'm going to be causing issues in my department. And that's the unfortunate place that a lot of folks are in, but for so long, again, going back to what you said, the standard answer has been to leave these items in there until it's absolutely unusable or absolutely clear, that there's all kinds of rust over the instrument. But there's a long way before it is so rusted that it can't even physically hold together to something that's new with a good passive layer on it. I just want to encourage our audience in the context of this interview, too, to, if you're on the front lines and you see this happen, stop the line, take that instrument out. Now, a question for you, if we start seeing corrosion happen in this process begin, is there any coming back from that? So say that we see some rust spots beginning in the hinges or in the box lock and we send it out for repair. What's going to happen when it gets to you?
Well, I think there is certainly a way back. And I think for the sort of technicians on the front line, I mean, it is an enormous challenge they have in terms of the volume of instruments that are processed and having to be as vigilant as they possibly can. But obviously, when you've got an instrument that's got 50, 100 instruments, a tray that's got 50 plus instruments on it, it's so hard to be able to pick up every minor blemish on the instrument. But I suppose it's looking at it from a point of view as, does my facility use RO water? In which case then potentially you're not going to have the issue with chlorides and things like that. So pitting potentially could be ruled out, because that won't necessarily happen in an environment when there's not chloride, although obviously you've got other issues that could also, those sort of chemicals can turn up in blood, of course, as well, and affect the instrument. But I think it's giving them the right education, looking at and distinguishing between the different sort of types of surface finish changes. So what does just a stain look like? It could just be a water stain, and it could present itself in slightly different ways. It might look slightly brown. It might be taken as rust, and it might not be. So things like that, yeah, you can clean. You've got Surgistain type products that can be used, acid-based products can be used to clean the instruments off. But of course, if you've got an instrument that clearly has pitting on the joint that's very close to the jaw, then then it should be a red flag. But I sort of think it's changing the mindset when we're looking to purchase the instrument, because quite often we've seen that you look across a tray of instruments and you think, right, so the money's been spent across the bits of kit that are seemingly the more important bits of the set. So on an orthopedic set, for instance, like the chisels, the osteotomes, and they've been bought from one of the sort of reputable companies. But then people are potentially skimping on things like sponge holders and mosquito forceps and towel clips, because it's perceived that they're not as important. Yet what potentially you can do is end up buying these cheaper instruments that perhaps necessarily aren't from the correct stainless steel, correct composition, and they can potentially affect the whole tray, cause washing, rust potentially across the whole tray, and really risking the integrity of the whole tray itself. So I think there's sort of just a few steps. It's, if we're replacing those instruments, let's look at perhaps spending a bit more money to get the better quality instruments for what are perceived to be it might only be a towel clip, but let's think about what's beyond that. If we go and buy a poor quality stainless steel towel clip that then rusts and causes the whole tray to need to be refurbished. But just going back to say the original question, of course, if you have got instruments that have got staining on, potentially they can be sent away to somebody to be refurbished, to be polished, to be repassivated, to be repaired. So there are ways back, really, and I think it's just a mix of maybe having some proactive maintenance, but it's all about budget, isn't it? And that's the thing, really. We're trying to sort of second guess what's going to happen. It's such a complex minefield as well. We still see a few sort of plated instruments on the sets, so there's no some of the sort of the older fashioned materials that we used. So there's always something there to catch the new technician out who might not be completely experienced in the huge variety you get across instrument trays.
Speaking of different materials, I know there's been quite a bit of buzz, not just in the surgical world, but also just within areas like home design, about metals that have naturally antimicrobial properties. Is there any chance that maybe that might be making its way into the surgical instrument world?
Yeah, I think so. I think you've got, first of all, potential for coatings that can offer this protection, and that are already being used in some instrumentation, things like rongers and things like that. But I mean, obviously, copper is and silver are well-known and natural antimicrobial metals, and we're seeing them being gradually drafted into different alloys. I mean, particularly copper. We've had some experience recently with a new alloy that contains copper. I think the issue is when all these things come about now, we look at, the MDR in Europe is in sort of full force transition wise, and I think it's you might have these new materials that come along that have these potentially, you could potentially have a stainless steel, a 420 stainless steel that has a bit of copper in it, that has a natural antimicrobial action, so it's killing bugs that's landing on the surface of it naturally. So why wouldn't you want that? But the thing is, I think we've got to be mindful that the MDR is laying down anything where there's a claim that there's antimicrobial activity on the surface of the material. We've got to look at a higher classification of device. So what it is for me, it's a big challenge, because you want stainless steel to move on. I mean, we've been using stainless steel for sort of 100 years in its current format, and we talked about it's a very good steel for surgical instruments, but it hasn't changed much since. Nothing's advanced, and now there's an opportunity for it to advance. I think obviously the regulations increasing with regards to medical device, and you've got to do a lot more to put these products on the market containing these more novel alloys, and I guess rightly so. People need to be safe, and if these new alloys are going to be used on them. But things like copper, obviously, it's a very well known scenario that copper has natural antimicrobial properties.
Daniel, as usual, we just learned a ton from you in a very short period of time in this interview. Great second appearance on the show, and I just want to thank you for coming on again.
No problem, it's my pleasure, and it's great to talk to you, and I look forward to seeing how things develop, and I think it's great to share some knowledge between our two countries. I think it's a really positive thing.
Fantastic. Thank you. That was Daniel Coole, Managing Director at Surgical Holdings. And I know, Mike, a lot of times people talk about the passivation layer. They don't necessarily understand exactly what that means other than they know it's a protective layer. I really enjoyed the section where Daniel told us a lot more about the details of the passivation layer.
Yeah, that understanding is so crucial for a lot of what's going on, particularly right now in sterile processing. This harkens back particularly to our first episode of the season with Lisa Wakeman about point-of-use cleaning and understanding why some of those chemicals that are used in our surgical procedures, particularly saline, with its chloride ions, are so dangerous to the integrity of the instrument. So it's a very important point of understanding to know why that point of use is so critical for the lifespan of those instruments.
Yeah, you read my mind going back to the first episode at the very beginning of Season 3. And I also want to just mention that conference at IU Health that Circle of Care is putting on is right around the corner. So absolutely, point-of-use cleaning and protecting that passivation layer go hand in hand. That's going to do it for this week's show. As a reminder, you can help support us by subscribing to Beyond Clean on iTunes or Stitcher, and now also on Google Play and Spotify. Simply search for Beyond Clean Podcast. We'd appreciate a rating and a review because your feedback is important to the show. And if you have any topics that you'd like us to cover on a future episode, or if you would like to share a picture anonymously on our Instagram page, just send an email to info@beyondclean.net. On behalf of Hank, Mike, and myself, thank you for listening to another edition of Beyond Clean.